In this question, I is a unit vector due east and j is a unit vector due north. Units of length and velocity are meters and meters per second respectively. The initial position vectors of particles A and B relative to a fixed point O are I plus 5j and qi minus 15j. A and B start moving at the same time. A moves with velocity pi minus 3j and B with velocity 3i minus j. Given that A travels with a speed of 5 meters per second, find the value of the positive constant p. So, well, we know then that the square root of p squared plus 3 squared is going to be equal to 5. And so that means that p squared plus 9 is equal to 25. P squared is equal to 16. And if we only want the positive, that means p is equal to 4. And let's make a note that the velocity of A then is going to be 4i minus 3j. Find the direction of motion of B as a bearing correct to the nearest degree. So it's going with 3i minus j. So here's north, and the velocity is 3 across and 1 down, 3i minus j. So it's down that way. So the angle we want as a bearing is this one. Let's just call this one alpha for a second. That's a right-angled triangle. So I can say that tan alpha is 1/3, and therefore alpha is going to be the inverse tan of 1/3. And I think my calculator's in radians from a previous question, so let's just change it. And then I want the inverse tangent of 1/3. And so that's 18.43 degrees. So the bearing is going to be 90 plus 18.43, which is approximately 108 degrees. So what do we want next? We want the position vector of A after t seconds. So we know that it starts at I plus 5j. And then every second it moves with this velocity 4i minus 3j. So that does that. Let's take the position vector of B after 2 seconds, so we'll better call that RA then. So RA is RB this time, sorry, is going to be, so where did B start? Started at qi minus 15j. And then its velocity is this one, isn't it? 3. This one here. So 3i minus j. Okay, so moving on. We want the time taken until they meet. So, well, they'll meet when the position vectors are equal. So if we look at RA, that's going to be, as far as the I components are concerned, 1 plus 4t. So I'm going to do these as column vectors. 1 plus 4t. And for B, that is going to be a q plus 3t. And then the j components is 5 minus 3t. And negative 15 take away t. So when they meet, looking at the j component, we'll have 5 minus 3t is equal to negative 15 take away t. So add 15 to both sides, 20 minus 3t equals negative t. Add 3t to both sides, 20 equals 2t. So t is going to be 10 seconds. So we now want to find the position vector of the point where they meet. So we know if t is 10, so this will be 41. And 5 take away 30, negative 25. And this one will be q plus 30. And of course that one has to be negative 25 as well. So q plus 30 is equal to 41, which means that q is equal to, find the value of q, that's down there. So position vector where they meet is going to be 41, negative 25, so 41i, take away 25j. And I'm not going to go to trouble of re-recording all of this to sort out the fact that I did something I didn't need to do there. I'm just going to say, let's move that down there, and q is equal to 11.